So at Giro, we have a relentless pursuit of new technologies. We are looking at anything. We are looking at any technology that allows us to reduce energy to the brain. So we've been evaluating the Mips technology for about 2 years, and by digging in and going deep on these issues and working with Mips very closely, we've been able to come out with the answers that we needed to move forward.
My name is Peter Haldin. I'm the CTO of Mips. I'm also one of the founders of Mips, and I'm also a PhD from Technical University in Stockholm, KTH, Royal Institute of Technology. The Mips idea was actually sprung out from what we could see in the human head and the human brain. We have the skull. Inside of the skull we have a small layer of cerebrospinal fluid, it's like water, and then we have the brain. We have the sliding layer, the skull can move a little bit and then damp out the rotational movement, otherwise transmitted into the brain. So what we did, we copied or mimicked this safety solution into the helmet. At an impact, a normal impact to the helmet will be compressed to the skull. And the scalp can move a little bit, but it's not very much. So the helmet will get stuck on the head. In a helmet with Mips, when we have an angled impact, the helmet can, as we have the Mips sliding layer, we have also sliding enablers attached to the EPS. It's a fabric, so making this plastic to move more easily, lowering the coefficient of friction. So at an angle impact, the helmet can rotate and slide like 10 to 15 millimeters. But what is most important is at an impact that we redirect the force by this relative motion. So a normal helmet absorbs or is designed to absorb energy in this direction, straight to the helmet, while a helmet with Mips is also designed for an impact in this direction where we have the rotation. So that is adding a new dimension into the helmet thinking. We went through hundreds of knockout movies, or movies from knockouts in boxing, and you could see the boxers standing hitting each other minute after minute, but then suddenly they got the uppercut or a hit where you get the rotation of the head, and that's always the knockout hit. During the years we have run thousands of tests in the Mips test lab with a significant reduction of the rotational accelerations and so on, so we're very confident that the system works. We've also seen third-party testing by Genetics in Canada, where they tested both bike, ski, motorcycle and American football helmets with a good result. Also Giro did a pendulum test of the Mips system with good results.
I think the Dome is a unique place that I don't see exist anywhere else with any other company. The ability for us to do our own prototyping in-house, the ability for us to do all of our own testing is very unique in the industry. And one of the questions we had was about the test fixturing and how testing for Mips or rotational energy actually worked. So we went back to looked at our own test rigs that we used to test linear energy. We looked at Mips's rotational energy test fixture, and by asking all these questions we decided that we needed another rig, and we came up with a pendulum style test fixture that incorporates a torso, a neck, an instrumented head. And what this allowed us to do was take the study, the research of rotational energy to the head even further.
There's still a lot of things to do and a lot of things to learn about the human brain, and especially when you look into different brain injuries. There is a need for much more research. I think the whole helmet industry will make a huge step forward within the next 5 years when it comes to improving the head protection.
Adding this Mips technology is just another example of what we strive to do here every day. We come in, we try to make products that are really fundamental to what we believe in, and that is the safety of the rider, whether it be bike or snow. And what we're trying to do is increase that level of safety, that level of protection that a rider has. Adding this Mips technology is exciting for us, and we look forward to the future where we continue to pursue technologies that will reduce energy to the head.